Supermarine. Most will remember this company for one thing, the Spitfire, which is totally justified. It was a gorgeous and amazing aircraft, and it is by far the most numerous aircraft they ever built. But in many ways, the Spitfire overshadows the rest of the company's history, particularly its early pioneering achievements in the development of flying boats. And that's why today we're taking a look at the earliest aircraft developed by the company, its curious origins, and how it influenced the birth of commercial aviation in Britain. But before we talk about that, I'd like to talk about the sponsor of today's video, Squarespace, whose wonderful service allowed me to create my website. Last time I showed you how I set up the homepage, and today we're going to make an updates section. Squarespace comes with a huge selection of pre-built pages, and among them are a collection of blogs that come fully pre-built with full functionality. Much like the homepage, the templates can be fully edited, so I got rid of all the placeholder stuff and set up my first proper post. I decided to use the pre-made text boxes as I had liked the layout, but those can be fully changed. Once you've written out your post, you can format the page to your liking, font, colours, sizes, etc. I prefer darker screens as it's easier on my eyes, especially when I'm spending so much time at my computer. The blog template has a bunch of built-ins you can utilise, such as SEO or keyword optimization, tags, comment settings, you can add various sharing functions, and you can add your location, because many blogs are often travel blogs. Sadly, I don't travel that much, but I do take a lot of plane-related photos, so I'll select one of these as my main image for this post. Once that's done, I can type up a little excerpt that'll show up on the main page, and it's done. It's dated, titled, photoed, and it has writing. And it has all of the social links that I built in a previous video already installed on the bottom of the page. Now, all of that was incredibly easy to do, and it didn't take me that long to make it all, my horrible want of decisiveness notwithstanding. But if you want to have a go at building a website for yourself, or your business, or even just to collect your thoughts or experiences in a blog, head over to Squarespace today for a free trial, and when you're ready to launch, go to squarespace.com/Rex'sHangar to get 10% off your first purchase of a website or domain. Once again, thank you to Squarespace for sponsoring today's video, and now let's explore the early years of Supermarine aircraft. Its history began with a man called Noel Pemberton-Billing. He was a man of changing passions: sailing, inventing, politics, music, and for a time, aviation. He'd taken an early interest in aeronautics, and this was almost his undoing. In 1904, he nearly killed himself by jumping off the roof of his house in a makeshift glider. But Billing was not deterred. Indeed, he was doggedly persistent, setting up his own airfield in Essex in 1909. Unfortunately, this venture failed within a year owing to the popularity of Brooklands. Following this, he dabbled in various things, property, the study of law, and he discovered what was to become a lifelong love of yachts. By 1912, he had a small business on the River Itchen in Southampton, and with the help of his business-savvy friend, Hubert Scott Payne, things were profitable. But aviation was never far from Pemberton-Billing's mind, and he was determined to build his own aircraft. But there was one small problem. Legally, he couldn't fly. He hadn't even been aloft as a passenger yet, but that wasn't going to stop him for long. In 1913, Billing made a bet with Frederick Handley Page, yes, that Handley Page, that he could get his pilot's license within 24 hours of first sitting in an aircraft. He won this bet, gaining license number 683, and Handley Page had to fork over £500, which was no small amount of money back then. Billing immediately used this money to complete his production facilities, and he officially founded his aircraft business, Pemberton-Billing Ltd. By this point, he had become obsessed with the idea of marine aircraft, so much so that he registered the telegraphic address of his business as Supermarine, a poetic choice as he wanted his aircraft to be the opposite of a submarine. And this leads us onto the company's first aircraft, though technically it made its public debut months before the company was officially registered. This was the Supermarine P.B.9, and it was shown off at the Olympia Aero Show in March of 1914. Its sleek lines were the work of Linton Hope, a yacht builder hired by Pemberton-Billing. He introduced advanced design techniques into the hulls of his flying boats, and his hull designs would be used by a number of manufacturers well into the 1920s. Though it made a striking appearance with its fish-like hull and flared sponsons, the PB-1 was a complete failure. It made use of a weak gnome rotary engine that just managed 50 horsepower, and it was angled slightly upward in the hopes of improving takeoff performance. In fact, this design choice had the reverse effect, providing not enough forward thrust, and the PB-1 never flew, even after a full redesign. Next, we have the PB-7, which was the start of an unfruitful obsession with the concept of detachable wings. Pemberton-Billing once said that he saw marine aircraft as not aeroplanes which float, but boats which fly, and the PB-7 certainly met these criteria. In these early days of aviation, this line of thought certainly had merit. Docking flying boats with shore facilities was a challenge that often led to bits of broken machinery. The PB-7 was intended to eliminate this problem. The aircraft would land in the shallow water near a port or other facility, moor itself, and then the hull, which was in essence a typical motorboat, would detach and head for the slipway. Designed to carry up to 6 passengers, the PB-7 was one of the most adventurous designs of the pre-war period. With an expected range of 200 miles, or 321 kilometers, it would have been more than capable of completing channel crossings with fuel to spare. It wasn't expected to be the fastest of aircraft, being powered by a single 225 horsepower Sunbeam engine, but the predicted top speed of 35 to 40 knots, or 64 to 74 kilometers an hour, was still enough to attract orders. Unfortunately, the only orders that were placed were for the German Navy, and by the end of the summer of 1914, completing said order was made difficult by something known as the Great War. By this point, some of the motorboat hulls were completed, and there seems to be some evidence that these were requisitioned by the Navy, but the PB-7 appears to have never flown. The idea of using detachable wings lived on with several of Billing's other designs, but these only ever existed on paper and never made it into production. With the outbreak of war, design focus shifted towards military aircraft. After the failure of the PB-7, and short of money, Billing accepted an Admiralty order to build 12 short S-38 biplane trainers. But he was not content to build other companies' designs. This led to the rapid development of a private venture, the PB-9. This aircraft is sometimes known as the 7-day bus, as it was apparently designed and assembled and flown in 7 days. But, as it turned out, this was not the case, as Billing had a talent for mixing truth and fiction with the skill of a veteran politician. His claims that he did the drawings in a day, and that the machine was built from scratch, have since been debunked, but in the stressful mood of a country going to war, some exaggerations were hardly uncommon. Designed, built, and flown in 9 days, the PB-9 was a stout-looking, all-wood, equal-span biplane. Contrary to previous claims, the aircraft was not completely designed and built by Pemberton-Billing. The wings were taken from the leftovers of the recently defunct Radley England Company. These were simple one-piece designs, and it took little effort to design a straightforward fuselage to go with them. In fact, the fuselage merely rested on the bottom wing and was attached by a handful of U-bolts. Hoping for a large production order, Pemberton-Billing designed the fuselage to be built from methods found in any joinery or cabinetry shop in the country. The main structure was built using mortise and tenon joints, and complexity was kept to an absolute minimum. Despite being built in such a hurry that people worried the glue hadn't properly dried, the PB-9 performed well on its first flight, and as an added bonus, all the important bits stayed in the right place. Powered by the same 50 horsepower engine that was used in the failed PB-1, it achieved a maximum speed of 78 miles an hour and a climb rate of 500 feet per minute. These were promising figures, but despite this, no orders eventuated. Instead, designs by the Royal Aircraft Factory had their production orders increased, and the disregard given to Pemberton-Billing's design thoroughly enraged him. Believing that government favouritism towards the Royal Aircraft Factory would prevent further work, Billing joined the Royal Naval Air Service and in October was granted a temporary commission as a lieutenant. He then took part in one of the first Entente bombing missions of the war, flying over Lake Constance to bomb Zeppelin hangars and their factories. Zeppelins would play a key part in the development of Pemberton-Billing's next aircraft, for while Billing himself was off with the RNAS, his company was still working to produce new designs. In 1915, the bombing raids by German airships posed a real threat to national morale. Not only was it terrifying, but it was embarrassing. So far, no British fighter had been able to intercept and engage these flying giants, and public and government pressure was mounting. The PB-23E, sometimes known as the Sparklet, was an attempt to correct this. It more than likely took heavy inspiration from de Havilland's Airco DH2, which predated it by more than 2 months. But whereas the DH2's nacelle was mounted directly on the lower wing, the PB-23's metal nacelle was mounted in the wing gap on a set of struts. It featured parallel chord unswept wings, with the lower wing having a pronounced dihedral. The twin fins and rudders were located inboard of the wide-span tailplane, and this was carried on a foreboom structure. Initially, it was powered by an 80 horsepower Roan engine, and it was equipped with a forward-firing Lewis gun. When it first flew in September 1915, the results were disappointing. It was reported to be underpowered, and its excessive rearward centre of gravity made it highly unstable. It failed to impress officials at the War Office, but the Admiralty saw potential. They ordered 20 examples of a modified version to be built, and this would be redesignated as the PB-25. In effect, it was almost a full redesign. The nacelle was lengthened and was now constructed from wood and fabric to save weight. Both wings were swept back 11 degrees to improve stability, so that it flew like a plane and not like an intoxicated seagull, and the engine was swapped out for a 110 horsepower closed-jet rotary. Owing to shortages, this engine was only installed on the first, so-called production PB-25, and the rest were fitted with 100 horsepower Gnome engines instead. The flight performance of the aircraft was somewhat improved, but pilots continued to register complaints. The biggest concern was the use of wood and fabric in the nacelle. It protruded so far forward that, in the event of a nose-over landing, the pilot essentially became the crumple zone for the aircraft. There was also the uncomfortable thought that the Lewis gun, mounted in the nose, could break from its mounting and quite literally run the pilots clean through if the impact was strong enough. Pancaking and weaponized impalement aside, the aircraft also proved difficult to handle, particularly during takeoff and landing, which increased the chances of the aforementioned incidents occurring. In the end, it appears that none of the PB-25s entered full service. This was partly due to the handling problems, partly due to a short supply of engines, and partly because of the dire need for reliable fighters on the Western Front, courtesy of the Fokker Scourge. Said Scourge, along with the continued Zeppelin raids, became key talking points for Pemberton-Billing when he made his way into politics. By early 1916, he had already become known for both his vocal support of air power and his vocal condemnation of the Royal Aircraft Factory. Though his opinion was certainly coloured by a personal grudge, he truly believed that Britain's other private manufacturers could build better planes. His critical views of the government and the Air Department meant the future of his aircraft company was uncertain. After all, you can't expect to get many orders if you tick off the people signing your checks. After some encouragement from Hubert Scott Payne and the other company directors, Billing sold his shares and moved on to pastures anew, which is a fancy way of saying the House of Commons. The company was officially renamed as Supermarine Aviation Works Ltd. During this transitional period, one more of Billing's designs would take to the sky, and it was by far and away the most outlandish. Hunting the German Zeppelins was proving to be troublesome. There was almost no warning of their approach, as they travelled at night, and by the time interceptors had taken off and climbed to their altitude, the airships had moved on. Pemberton-Billing, continuing his trend in unorthodox designs, came up with the idea of a fighter that could remain in the air for the entirety of the night, climbing to altitude at dusk, performing its patrols, and then landing at dawn. Because of this long endurance requirement, a large amount of fuel was needed, which itself meant that the aircraft on a whole was going to be pretty big. With 4 wings, 2 Austro-Daimler engines, and looks only a mother could love, it was certainly an interesting design. It was to have a crew of 3, a pilot, observer, and gunner, and it was expected to have a flight endurance of 10 hours. The PB-29E was known in-house as the Night Fighter, and it apparently flew for the first time in Essex on the 16th of January 1916. I say apparently, as the only actual evidence of this was a reference to the flight that Billing made in a speech during the Mile End by-election. Later flights certainly took place, and it was flown by several pilots of the Fleet Air Arm to evaluate its performance. But said performance is difficult to determine, as the PB-29 was then destroyed in an accident several weeks later. This was not the end of the project though. The Admiralty maintained enough interest in this lumbering Zeppelin hunter to justify further development, and so when the company had been reorganised as Supermarine, work began on an improved version known as the PB-31E. One of the company's new designers, a young man by the name of Reginald J. Mitchell, took Billing's early design for an improved PB-29 and modified them further. Mitchell would go on to design several of Supermarine's best aircraft, including the Spitfire. But all of that was still ahead of him, and it could be felt that this was given to him because he was the new boy. The quadruplane wings and biplane tail were retained, but the whole structure was significantly strengthened. The fuselage and cabin was almost completely redesigned from the ground up, and the Austro-Daimler engines, which were installed as pushers, were now replaced by 110 horsepower, 10-cylinder Anzani tractors. Known as the Supermarine Nighthawk, it was not the most visually appealing plane ever made. In fact, it took #1 spot in a video that I did which covered the ugliest aircraft ever made in Britain. But despite being a visual horror, it was an overall improvement. Not only did it have better engines and a sturdier airframe, but its firepower was increased. The main weapon was now a 1.5-pounder recoilless Davis gun, mounted in the main gunner's station, and this was complemented by a Lewis gun in the nose and another mounted in the rear. The Nighthawk also featured some novelties which had yet to make their way into aircraft thus far. The first was the provision of a bunk in the pilot's cabin. The Nighthawk came with 2 pilots, and each would take turns resting during their bumpy 10-hour patrols. The second was the installation of a small searchlight mounted on gimbals in the nose. This was not only useful for illuminating enemy airships, but also for takeoff and landing at night. A perilous affair in something that more resembled a flying tower block rather than an actual aircraft. Despite being generally underpowered, the Anzani engines allowed a maximum speed of 75 miles an hour, although the usual patrol speed was 60. And a positively sedate landing speed of just 35 miles an hour was usual. Despite all the work put into this ill-looking project, the Nighthawk would never get a chance to do its job. It was tested several times by the Navy, beginning in February 1917, and a second model had been ordered, but this order was cancelled a month later and no production orders ever came. This is mostly because conventional interceptors were now achieving the performance required to effectively hunt and engage Zeppelins, rendering the Nighthawk completely useless. Following the Nighthawk, we come to an odd period of Supermarine history. Immediately after the departure of Pemberton-Billing, the company needed to secure work, and this came in the form of aircraft designs from the Admiralty Air Department. The 2 aircraft that were contracted to Supermarine were the A.D Boat and the A.D Navyplane. Work on the A.D Boat had begun during Pemberton-Billing's time, and the 2 prototypes were in the middle of their flight tests when the company changed to Supermarine. Like many of the earliest flying boats, and these were among the first, they were plagued with hydrodynamic problems. It suffered from chronic porpoising on takeoff, and it had some truly alarming yaw defects. To get up safely, it had to be initially pointed downwind, and then as the speed rose, it had to be gradually turned into the wind. This turned out to be the result of the rudder and fins being too small, which meant that control at slow speeds pointing into the wind was presumptively optimistic. Eventually, the kinks in the design of the hull, placement of the engines, etc. was worked out, but by this point it was late 1917 and they were effectively obsolete. Designers at both Supermarine and the Air Department had learned valuable lessons though, and these lessons in particular would help Supermarine achieve fame in the not-too-distant future. Additionally, though their time at the military had passed, the A.D Boat would continue to see use with Supermarine in the civil sector, but before those are covered, there are 2 other aircraft that need mentioning. The A.D Navyplane was originally an Admiralty design, but it was given to Supermarine to complete. As the detailed design work and all of the construction was done by them, it can probably be considered a Supermarine aircraft more than an Admiralty one. It was completed as a 2-bay biplane. Accommodating a crew of 2, its lightweight nacelle was fitted with a Lewis gun and came with a wireless radio. To avoid the prop wash, which often interfered with tail control, the tailplane was raised up as far as possible. It was completed with pontoon floats, though there were originally plans to use those developed by Linton Hope, but the earlier models had proved to be unstable, and the Admiralty preferred their men and equipment to not sink. The Navyplane was intended for reconnaissance and bombing duties. Because of this, the central part of the nose was glazed over, with this extending underneath the front pilot's seat, and this provided excellent views for both reconnaissance and bomb aiming. Unfortunately, the Navyplane would never get to test this feature in action, as it never made it to production. It had been equipped with the infamous Smith static radial engine, which had also powered the twin Blackburn that I covered in an earlier video, and it was woefully underpowered. Because of this, only the first prototype was completed. It was refitted with a radial engine built by Bentley, in a hope of salvaging the design, but this also proved to be a disappointment. Air-cooled radials were still proving to be a challenge to get right at this time, despite their advantages in saving space and weight, and converting the Navyplane to a liquid-cooled engine required too much work, and so the design was eventually abandoned. Later on, an improved version of the Navyplane was attempted as the so-called Supermarine Patrol Seaplane. This was intended as a potential replacement for the short 184, which didn't really need replacing as it was performing perfectly fine, but the Navy was looking for one anyway. It was to have a crew of 2, be capable of carrying 4 100-pound bombs, wireless equipment, signal gear, and a handful of carrier pigeons. Contracts were placed for the design to be built by Supermarine, Phoenix, and Schultz, but one by one these were all cancelled. Not only had the Navy realised that this replacement was totally unnecessary, but Supermarine were busy working on a far more promising project. Of all their early designs, the adorably named Supermarine N1B Baby is perhaps the most important. The Sopwith Baby, also built by Fairey, had been the Navy's main single-seat fighter since 1915, but by the end of 1917 it was getting a bit long in the tooth. To address this, the Air Department issued specification N1B. This called for a single-seat fighter that had to be either built as a float plane or a flying boat. It had to be able to be launched from a ship if needed, it had to have a top speed of 109 miles an hour at 10,000 feet, and a maximum ceiling of 20,000 feet, which was a huge ask when the reliability of most engines at the time could be best described as dubious. The task of designing this new machine fell to Supermarine's chief designer, F.J. Hargreaves. Assisted by R.J. Mitchell, who had worked on the Nighthawk and the Navyplane, he designed and built the first single-seat flying boat to be operated by the United Kingdom. Whereas every previous design of flying boat had some sort of major unforeseen drawback, the Supermarine Baby was the first where everything seemed to mostly work straight away. Its hull was the tried and tested design by Linton Hope, who had built previous bodies for both Pemberton-Billing and Supermarine by now. The previous problems with porpoising had been mostly overcome, and its redesigned step allowed it to get onto the waterplane and stay on it much easier. Following experiences with the A.D boats, an inverted camber tailplane was chosen, being mounted above the single fin and rudder, with a smaller fin on top. This was done to address the issue of lateral control at low speeds. The single-bay wings were robust and could be folded backwards for easy storage aboard a ship. Initially, ailerons were fitted to the upper wings only, but they would later be installed on the lower wings as well. Propelling it through the water, and then the air, was a 4-blade propeller driven by a powerful 150 horsepower liquid-cooled Hispano-Suiza V8. When it first flew in February of 1918, the Baby exceeded expectations by achieving 117 miles an hour at sea level, making it both the smallest and the fastest flying boat in the world. In the air, it was considered almost viceless, pilots praising both its speed and handling, and on the sea the only real problem was a tendency to ship water. The engine and propeller were positioned to minimize the effect of spray during takeoff, but Hargreaves had underestimated the aircraft's capacity for acceleration, which forced the nose down and thus forced water up, which rather quickly exposed a major drawback of the open cockpit when sitting upon a body of water. But aside from this issue, the baby was well received. To deal with the water problem, Hargreaves drew up 6 different design modifications to the hull, and while these were being reviewed, they also upgraded to a 200 horsepower Sunbeam Arab engine. With 33% more power, the aircraft was not only faster, but it was deemed powerful enough to safely complete aerobatic maneuvers. And later on that year, the baby became the first flying boat to complete an inverted loop. Despite its impressiveness and the placing of a production contract, the aircraft was never put into service, with just one example being built. This was the result of 2 things. 1. The Royal Naval Air Service was now capable of launching aircraft from ships, utilising Sopwith pups aboard early aircraft carriers, as well as launching them from battleships and cruisers that had been re-equipped with specialised platforms. 2. By the time work was underway on the first production models, the war was over, and there was little need for them. Though they would never be flown, the design modifications to the second and third aircraft would be found in several successive Supermarine designs. Some of these would achieve fame for themselves and the company when competing in the Schneider Trophy races of the 1920s. Though the end of the war curtailed the potential success of the Supermarine Baby, it did lead to the success of another aircraft, the Supermarine Channel. In early 1919, the company was rapidly making plans to enter the commercial market. The plan was to establish coastal flying services, both for tourism and commercial use, around the southern coast and the Isle of Wight. The now surplus A.D flying boats were chosen as the best aircraft for this task. They were already built, they were now thoroughly reliable thanks to multiple modifications, and the Admiralty was keen to offload them. 10 A.D boats were purchased from the Navy, and as early as February, the first drawings for their design conversions were already being produced. The conversion involved the installation of a second cockpit just forward of the wings, the replacement of the 200 horsepower Hispano-Suiza engine with a 160 horsepower Beardmore model, though less powerful they were more reliable and more readily available, and the fitting of a water rudder to improve low-speed water handling. With the additional cockpit, the aircraft could be used as a dual-control 3-seat trainer at coastal flying schools, or, with some slight modifications, it could be used as a 4-seat passenger aircraft. The latter would turn out to be the most common. Of the 10 A.D boats that were purchased, 5 were intended for active service, with the others held in reserve. This was to allow servicing and overhauls to be carried out without the flying service itself being affected in terms of delays or cancelled flights. In 1920, when all design drawings were changed from Admiralty to Supermarine nomenclature, the name Channel was selected, seeing as it was those waters in which it would operate, but by this point the aircraft had already been in service for over half a year. As soon as the first Certificate of Airworthiness was granted, which was July 23, 1919, Supermarine began using the channels for joy flights, and they also set up their first passenger service, running from Southampton to Bournemouth. Things developed quickly after this, and by the end of 1921, the channels were operating multiple routes, both domestically and abroad. To cover their entire use and history is well beyond the scope of this video, but I will quickly cover it in a general sense to give an impression of just how much these aircraft achieved in a relatively short time. In August 1919, they began operating a service between the mainland and the Isle of Wight, often carrying prominent officials, members of parliament, or private passengers. That same month, another channel was used to supply petrol to the Ventnor motorboat service, the first time fuel had been transported commercially by air. One of the channels was also used by Supermarine Managing Director Hubert Scott Payne as a personal transport during the 1919 Schneider Cup. The British Railway strike of 1919, which began in September, provided even more opportunities for the company. The Southern Daily Echo, which was based in Southampton, hired a channel to transport their newspapers to Bournemouth. The flight took 43 minutes, which by today's standards puts it on par with travelling by car, but for 1919 this was a blistering pace, and did much to display the potential for commercial aircraft. Scott Payne further capitalised on the strikes when the cross-channel steam packets also joined the industrial action. He quickly established the first international air route for flying boats, selecting 2 channels to fly the route between Woolston and Le Havre. This required crossing just over 100 miles of sea on a daily basis. Easy enough by ship, but regular channel crossings by air were still uncommon, and it created quite the sensation. The cross-channel route was inaugurated on the 20th of September, and although the strike ended just a week later on the 5th of October, the channels had made quite the impression. Scott Payne had been adamant about operating the service in all weather conditions, keen to dispel the doubts that commercial aircraft were unreliable in poor weather. This led to the channel flying its service during a roaring gale on the third day of operations, carrying a naval officer and a Belgian banker through a storm that varied between driving rain, freezing sleet, and painful hail. The gale was so severe that the wind at times reached over 100 miles an hour, resulting in a channel crossing that took over 5 hours to complete. But it was completed safely, and both the aircraft and its passengers arrived in France. Cold, but completely unharmed. The channels quickly found service overseas. They were operated in Bermuda, Chile, Japan, Norway, and Venezuela. Some of these were operated as commercial transports, carrying passengers, mail, or both, but others were ordered as military aircraft. Along with ordering a trio of channels for commercial use, Norway ordered 4 more to be used as naval seaplanes. Little is known of their operational history. One of the first was delivered as a 3-seat training model, and another was used for a postal service, but it is clearly evidenced that they were not happy with the Beardmore engines. They re-equipped 2 of their channels with the more powerful 250 horsepower Siddeley Puma, a configuration which had been contemplated back in England, but not settled upon. However, upon reviewing the improved performance of the Puma-equipped channels, which boasted a top speed of 92 miles an hour, Supermarine also started to use the engine, and these aircraft were known as the Channel Mark II. Mark II channels were purchased by the Imperial Japanese Navy, who ordered a trio in March 1921, and another was bought by the Royal Swedish Navy a short time later. The last channel to be built was delivered to Chile in 1922. Ostensibly designed as a 3-seat Mark I, it featured a completely different hull design that was more in line with the recently developed Supermarine Sea Eagle. But for whatever reason it was officially listed on record as a Mark II channel and entered operations with the Chilean Naval Air Service. Despite their successes in the commercial air routes, most of the channel services were stopped by the end of 1921. Many businesses and politicians had yet to be convinced of the viability of commercial air travel, particularly flying boats, and though this mood would be reversed in a few short years, the interest was not yet strong enough for the channels to be a commercial success. There were also some highly influential people who had large investments in rail and shipping, and their lobbying led to such a high surcharge for airmail that it was just as affordable to simply pay for a telegram. The Air Ministry was aware of this situation. Indeed, 1919 to 1921 could be considered the battleground years where aircraft manufacturers the world over were fighting for their very survival. To encourage the development of commercial aircraft, and to show the public there was long-standing government interest in aviation, they announced 2 development competitions in 1920. One was for land planes, and the other was for seaplane amphibians, and this is where the inventively named Supermarine Commercial Amphibian comes in. The requirements in the competition were as numerous as they were specific. Each aircraft had to carry at least 2 passengers, airframes and engines must be fully designed and built in the British Empire, the aircraft must remain buoyant if a section of the hull or floats is perforated, the aircraft must cover a range of 350 miles at no less than 70 knots at 1,000 feet, carrying a useful load of 500 pounds, and there were also numerous requirements for self-controlled flight, meaning the pilots had to take their hands and feet from the controls, and the aircraft was expected to fly safely for a set period of time and distance, both with and without engine power. 3 companies submitted aircraft for this competition: Fairey, Supermarine, and Vickers. The commercial amphibian was designed and constructed in a hurry, the company being so busy with the channels that the competition caught them off guard. The hull followed the now well-established Linton Hope designs, with 2 skins of mahogany, the inner laid diagonally and the other longitudinally. The whole lot was then covered in doped fabric, and this was then finished in the usual varnish and polish used in boat building. The unequal span wings were non-folding, with ailerons fitted to both, and a rotatable tail skid was installed which could also serve as a rudder. The amphibious undercarriage was a simple pair of steel structures hinged under the wings, and the engine selected was the 350 horsepower V12 Rolls-Royce Eagle. This made the aircraft the least powerful of the competition, but Supermarine designer R.J. Mitchell was still confident of success, owing to the robust build quality of his design. After all, he wasn't building a racer for speed, he was building a transport for safety and economy. Unfortunately for Mitchell, the lack of power proved to be their undoing. The commercial amphibian completed all of the required tests: self-controlled flight, unpowered flight, low and high power water trials, high and low speed aerial trials, and mooring and poor weather exercises. Throughout the whole of these trials, no adjustments, repairs, or replacements had to be made, and it was the only aircraft to complete all of the assigned tasks. The amphibious undercarriage was particularly praised, with both Vickers and Fairey having issues with theirs, and the layout of the flight equipment within the hull was considered to be the most sensible. But, and this was a big one, the Supermarine was considerably slower than the competition, and this hurt the score when it came to overall flight performance and fuel efficiency. Both the Vickers and the Fairey aircraft had the more powerful 12-cylinder Napier Lion, which put out 100 horsepower more than the Rolls-Royce Eagle. Because of this, the Vickers Viking would win the Air Ministry's competition. Supermarine would come second, but the Ministry had been so impressed with their design that they doubled the consolation prize to £8,000, which today would equate to about £250,000, though the buying power would be even greater still. This certainly took the sting out of the defeat, and R.J. Mitchell had plans to improve upon the design of the commercial amphibian. Unhappily, these were never realised, as it was crashed just a month after the competition. Instead of building a second, a development of the commercial amphibian was decided upon instead. And this leads us to the last aircraft of today's video, the Supermarine Sea Eagle. The Sea Eagle was a response to a rumour that government was considering an official and permanent air route between Southampton and the Channel Islands. R.J. Mitchell began design work on this upgraded amphibian in March of 1922, adding the provision for folding wings, an enclosed forward cabin for passengers, and improved mountings for an uprated version of the Rolls-Royce Eagle. By June of 1922, when the Air Ministry approved air routes between England, France, and the Channel Islands, Mitchell had further consolidated his design. It would now carry 6 passengers in the enclosed cabin, with the pilot and mechanic in a raised cockpit further aft, and the engine was now confirmed to be the Rolls-Royce Eagle 9, putting out 360 horsepower. While construction of the prototype was underway, Supermarine and Southern Railway, who owned the Southampton docks, formed a subsidiary, the British Marine Air Navigation Company. At Supermarine's Woolston facility, they established Britain's first commercial flying boat terminal, and the Air Ministry agreed to pay them a subsidy to purchase 3 Sea Eagles and spares to operate the new air routes. When completed, the Sea Eagle was first flown in June of 1923 by ex-RNAS pilot Henry Beard. I apologise if that's pronounced incorrectly. He was born in England, but his father was French, and some sources have his name as Henry Baird, and others as Henri Beard, and I've decided to go with the latter. Before beginning commercial services, he entered the Sea Eagle in the 1923 King's Cup air race. The aircraft did better than expected, being virtually untested, and it came in 3rd place. It also ran for a remarkable amount of time at full power. Beard's average speed for the race was 91 miles an hour, and the Sea Eagle only had a top speed of 93. Following the race, the Sea Eagle gained an unexpected but powerful admirer. On the 5th of August, Sir Sefton Brancker, Director of Civil Aviation in the Air Ministry, visited the Woolston Works and was offered to go for a flight in Supermarine's new aircraft. Along with 5 other passengers, he was taken for water demonstrations of its seaworthiness, darting between the various moored ships in Cowes Road. The Sea Eagle then took off, circled the Royal Yacht and its guard ship HMS Barham, and returned to Woolston about an hour later. Sir Sefton was impressed by both the performance and the comfort offered by the Sea Eagle. Not only did it provide a smooth and relatively quiet flight, but the placement of the engine meant that oil and fumes did not enter the cabin, and the passengers were provided with wonderful forward views. He would spend the rest of the decade encouraging public interest in civil aviation, and his often preferential treatment towards flying boats can be attributed to his initial experience aboard the Sea Eagle. Unfortunately, he would perish in the disastrous maiden voyage of the R-101 in 1930. Sea Eagles began regular service between Southampton and the Channel Islands on the 25th of September 1923. Due to constant nitpicking by customs authorities, who insisted on things being as clear and understandable as possible to passengers, workers at Woolston, in a mild huff, had painted the word airport on the roof of their shed in large lettering. Apparently, the concept of an aerial port was difficult for some to understand. Though this may have been a large case of sarcasm, as the sea ramps and aircraft facilities made its function abundantly clear, it is perhaps the first recorded use of the word airport in the way that we use it today. By the end of November, over 180 passengers had been carried between the Channel Islands and the mainland, but the service to France was never established. This was partly due to a breakdown in negotiations with the French ports, and partly due to a reduction of government subsidies, which reduced the number of Sea Eagles that could be built and maintained. The Channel Island service ran smoothly throughout 1923 and into 1924. But although they were successful, a lack of orders was not generating Supermarine the money it needed. Scott Payne, its managing director, was becoming more and more involved with the affairs of Supermarine subsidiary, British Marine Air, rather than the company itself. This led to conflict with Supermarine's other director, James Bird, who eventually convinced Scott Payne to sell his share of the company. Not long after this, British Marine Air would merge with Handley Page Transport and the Instant Airline to form Imperial Airways. Scott Payne became one of the new directors, and it was a position he would hold until 1939. 2 of the 3 Sea Eagles would resume service under this new banner, but the original was crashed on the 21st of May and was written off. Their time under Imperial Airways was short-lived. The service ran for about a year before being suspended in the summer of 1925. By now, more advanced flying boats were coming onto the field, not only by Supermarine, but ones built by Blackburn and Shaw Brothers, both of whom had invested into larger aircraft while Supermarine had slackened under Scott Payne. The Sea Eagles got a second win in 1926, as the demand for seaplanes outstripped the supply, but the third was accidentally rammed and sunk at its moorings in January 1927, leaving just the second to carry on. This it did until 1928, when it was finally retired in favour of the short Calcutta. It was an inglorious end to what had been the instigator of the first long-term regular air service in Britain. Though the air route itself would be terminated in 1929, others would take its place, and between 1924 and 1928, the Sea Eagle had fully demonstrated that commercial air travel in Britain was not only viable, but it was safe and economical. Now, those of you who are more knowledgeable on Supermarine aircraft may have noticed this video is not fully complete. There were a few aircraft developed before or during the time of the Sea Eagle that I have not yet mentioned, such as the Sea King, the Sea Lion, and the Seal, to name a few. That is because these aircraft are ones that are best remembered for their participation in the Schneider Trophy races. That is a topic that is definitely getting its own video, and in that I'll be discussing the aircraft that took part in the various races. In all honesty, that will probably be a multi-part video because it's a pretty extensive topic. I don't have an ETA for when that would even be out. I've done some preliminary work on it, but there is just so much more research to do, and I've got a bunch of other long videos that I started planning before it. But rest assured it is coming. However, this does mark the end of today's video, covering the early days of Supermarine aircraft. As always, thank you all so much for watching, and a big thank you of course to the patrons, especially those who voted on today's video, and a big shout out to the wing commanders, the senior officers of this special group. Apologies if I missed anyone this week. The new video schedule means that I have to record further ahead of time, but you'll get a mention in the next one if I've missed anyone from this week. And hopefully my voice wasn't too bad. I'm still dealing with this long COVID crap and it's thoroughly exhausting. Just send me a new pair of lungs, please. Alright, thank you all so much for watching, and I will catch you all next time. Goodbye.